Welcome to the project demonstration of a LoRaWan based open source IoT solution for monitoring rural electrification policy. So here we are going to send the rural electrification data like solar power along with voltage and current, and the charged battery voltage and current, and also how much of load is consuming the voltage and the load also. So these 6 parameters will measure with help of these 3 sensors continuously by our UNO board, and then based on that we are going to get the environmental parameters like humidity and temperature from this DHT11 sensor. Totally 8 parameters will be uploaded to the ThinkSpeak cloud platform by sending the same information through the LoRa transmitter and LoRa receiver. So the data will be received by our Raspberry Pi 0W here, and 0 that data will be processed and sent to the ThinkSpeak cloud platform with help of ESP8266 module. So this is the input to the output. So let me explain the component wise. This is the 12 volt 5 watt solar panel which is used to charge our 12 volt 1 amp battery. This battery pack consists of 3 4 volt 1 amp batteries are in series, so we will get 12 volt 1 amp which is a rechargeable battery. So in our project we are going to recharge this battery in 2 ways. One is the solar panel, another is grid. So from this transformer we can charge a battery. So there I wrote T or S, transformer or solar panel. So this is a charging circuit. So that it consists of mainly 2 parts. One is rectifier and there is a filter. So when we charging the battery from the transformer, then this DB107, so the IC name is DB107, which will act as a AC to DC converter. So when we providing a AC input, so if we provide DC input from the solar panel, this rectifier will act as a polarity corrector, nothing but if you provide the reverse connection from the solar panel. So if you make any like reverse connection, then that DB107 will act as a polarity corrector. So it will convert the reverse polarity to the actual polarity, which is same polarity of the battery, and that it is given as input to the battery through this smoothing capacitor, and this is the main on-off switch. So from here we are going to provide the supply to the battery. Once the battery is charging, so it will provide the supply for the load also through this current and voltage sensing circuitry. So from here we are going to measure the solar panel voltage, and from here we are going to measure the battery voltage and current, and parallelly from here we are going to measure in the load parameters. And this is the DHT11. So coming to the load ratings, so we are using 12 volt 1 amp load DC motor, and DHT11 nothing but digital, humidity, temperature, and this LoRaWan directly. So the interfacing connections at the transmitter section, so this one is connected the voltage sensor of the solar panel at A0, battery sensors at A1, and load sensors at A2, and the LoRaWan is connected at pin number 8 and 9, and DHT11 at 10th pin. So they are the interfacing connection to our UNO board. So once the data is transmitted from here, so the LoRaWan here receiver and receive the data, and it will provide the data to the Raspberry Pi 0. So then it will process that and send the same information to the ThinkSpeak cloud with the authentication API key with help of ESP8266 module. So let us see the demonstration before switch on the kits. So let me explain you the charging process. If you want to charge a battery from the grid, so you need to connect the transformer to T slots and then provide the AC 230 volts inputs, and then there is a light indication on the charger. There's a light indication on the charger. So the battery will be fully charged in a duration of 8 hours if you charge either from solar panel or grid. So once the 8 hours is completed, you can disconnect the charger of this grid connection, and while demonstrating in the college, just you can show the with solar panel directly. Right. So I connected the solar panel here. So as you can see that due to this tube lighting also you will get little bit of voltage. That's why the LED is blinking in low intensity. And then after, the next step is switch on the hotspot settings of your phone. So change the hotspot settings in your phone. So go to hotspot settings and change the hotspot name to project 4970 without any space and without any capital letter, and the password should be 129. So after enabling the settings on the hotspot, on the data, and log into the ThinkSpeak from the given credentials and provide this power supply to the both kits, receiving and transmitter at a time. So once you switch on that, so then there is an indication of the device got connected. You can see that in your phone. So one device is connected, right? So this is a previous data. So if you want to get the fresh data, so before erasing that, better to download the data for a backup purpose. Go to data import and export, and in that download, so the data will be downloaded and you can open that. So there we can see the data along with time and how many number of entries till now it got stored, along with 8 parameters. So there we can see only field 1, field 2, field 3. So field 1 to field 8 is nothing but solar panel voltage current, battery voltage current, load voltage current, humidity and temperature. So right, there you get the data in this manner along with date and time. So after you download the data, you can clear the channel. For that, next go to channel settings, and there only do clear channel. Don't do delete channel or any other things. Only do clear channel. Right. So now go to private view. Now there you can see the data now. So the whole data will be erased, and the data uploading speed from the system to the ThinkSpeak cloud is at a rate of 15 seconds of duration, as ThinkSpeak accept only in 15 seconds duration. Okay, right. So we got the fresh data. So meanwhile, if we switch on the motor load, so battery voltage. So if you demonstrate this project at least of 10 minutes, you will get the sufficient readings as a graphical presentation for each and every parameter. Alright. Okay, in this manner we are going to get the parameters data from the generation station to the monitoring station, and also continuous monitoring on ThinkSpeak cloud platform.